Okay. You ready?
Yeah.
Okay. Kia ora, everybody. Kia ora, everybody. Nice to have you here today, whether you have joined us via a physical hub or via Zoom out there. We are presenting to you today from Greta Point in Wellington, NIWA in Wellington. It's a pleasure today to have Ilan Noy of the Victoria University of Wellington presenting on his research into the EQC and climate change. I'm actually going to leave it to Ilan to introduce himself, but just spend a little bit of time doing some Zoom housekeeping with you so that the seminar runs as smoothly as possible today. So if you are in a hub and you can't see yourself on video, could you please use the chat function in Zoom to let me know so that I can promote you to a panelist, which means we'll be able to see you online. Question and answers today. If you're in a physical hub, you can raise your hand and we'll be able to see you. Please leave it to us to unmute you. And because people ask questions in lots of different ways, we want to make sure the order is orderly. If you are using Zoom to ask your question, to type your question, please don't use the chat panel. Please do use the Q&A panel. You can access that via the menu bar on the bottom of your Zoom screen. If failing all of that, you can't work out how to ask a question, you can send me an email and I'll slot you into the line. You will have my email on your Zoom invite. So I hope that all is as clear as mud, and without further ado, I'll pass over to Ilan Noy. Thank you very much. Thanks, Ilan.
Thank you very much. I was told I need to introduce myself. So my name is Ilan Noy, and I'm a professor of economics and a chair in the economics of disasters at Victoria University, which is going to soon change its name to Victoria University with small font for Victoria. I don't know if they can see, everybody can see the slides, yes? Excellent. So this is a talk about the Earthquake Commission and climate change. This started with a proposal for a project about 3 years ago when we realized that there's actually has been very little quantification of the exposure of the Earthquake Commission to weather risk. And basically we proposed at the time 3 separate pieces to this project. The first one was just looking at the past claim data from the EQC and trying to tease whatever information we can from that data, which is the first stage of the project, which I'm not going to talk about today because we had a Deep South seminar on that about 1.5 years ago or something like that. I'm going to largely skip over that. And then I'm going to talk about the 2 further pieces to this project, which is the looking at the efficiency or the efficacy of the past insurance payments in generating recovery at the local level, and doing some quantifications of future EQC liabilities because of climatic change. So that's the 2 parts I'm going to focus on today. I'm happy to take questions as we go along or at the end, whatever is at the end I was told. So we'll take questions at the end. I should note that the core team working on this is myself with David Fleming, who used to be here and then decided to swim across the Tasman to Brisbane. And then Sally and Jacob, who are in the audience today. So all the hard questions should be aimed at them rather than at me. This is a project funded by Deep South, as you are aware. I also want to specifically acknowledge Izzy and Abba, who have contributed significantly to this project and are actually co-authors on one piece in this. There's other people who worked on this as well, including some people from NIWA, from Victoria, and so on. A little bit about the EQC cover in case you're not familiar with it. So everybody knows that EQC provides cover for seismic events, but it also provides cover for rainfall-induced, or what we call wet landslips. The cover it offers for wet landslips is exactly the same as it offers for earthquakes, so full cover. But for storms and floods, it only offers coverage to the land rather than to the dwelling. Like all of EQC cover, it's all conditional on you having private insurance. But since practically everyone in New Zealand does have private insurance, then that basically means that it's universal coverage. And what it covers in terms of the land is the land under the building, including an 8-meter strip around the building and access points to the building, or the main access point to the dwelling, including bridge and culverts and retaining walls that are essential to the, I don't know, whatever. There's a whole lot of detail on that, which lawyers, of course, celebrate, but the rest of us probably don't. If we look at the data in terms of what we were looking at, so the main pieces of information we had is the record of EQC claims in the past. This is just the EQC weather claims. So we have 26,000 observations, or 26,000 claims for damage associated with weather events. The EQC only categorizes them as one sort of in one bucket, so we can't really differentiate between which ones are because of landslips, which ones are because of flooding or storm damage. They've recently changed their systems, so going forward we will be able to tell the difference, but right now we're not. And so we started with 26,000 records. We had to narrow it down because there was some missing information on some of them. But if you want to see the map, that's basically the map where these claims were. So not very surprisingly, it's where people are. Okay, but if we look at the distribution in per capita terms, and there are some surprises. So some areas are more heavy users of this insurance cover, and all of that is described in chapter 1 in paper 1, which was out last year. It's publicly available, so if you're interested, please read it. Just maybe one piece of information that we found interesting when we did this analysis, that looks at all the properties in New Zealand and on what kind of slope they're located. And what you can see from this is that the buildings that submitted EQC claims are on much steeper slopes than the standard building in New Zealand. So if you look at the very left-hand side bar, about 50% of buildings in New Zealand are basically on flat ground, but only about, 18% of the buildings that submitted EQC claims are on flat areas, suggesting it's already a hint that most of the claims are not associated with flooding in flood zones, but rather are associated with landslips. But there's much more analysis on those aspects in the first paper, and I'm not going to talk about. For the second paper, so what we did in the second paper, we chose 3 recent events, and why we limit ourselves for 3 recent events I will explain in a second. But we looked at the 3 costliest events according to the Insurance Council in terms of insured damages in the past few years. And this is one event in 2015, one in 2016, and one in 2017. We wanted to analyze what was recovery like from those events. So this is we identify where those events occurred using rainfall data from NIWA. So we looked at basically at all the locations that received all the properties in New Zealand that received very heavy rainfall during those days of the event. Okay, so we know the days of the event, we know the rainfall in those areas, so we can identify for each property in New Zealand whether they received a lot of rain in that area. And that's the yellow or green or whatever it is, the color, whatever colorful color there is there. I'm colorblind. So those are all these properties that received very heavy rain in those 3 events. The dark dots, the black dots, are the ones that submitted an insurance claim to the EQC. We would have loved to know who submitted the claim to the private insurers, but alas, we don't know because private insurers don't share data. So what do we do with that information? We are basically identifying using that sample of all these properties that experienced extreme rainfall during this event. We are trying to estimate the recovery. How do we measure the recovery? Using nightlight data. So this is data available from NOAA, the National Oceanic and Atmospheric Administration from the US, which provides these monthly nightlight pictures globally. So the average nightlight, I think it's measured at midnight or something like that. And they average it over the month because there's some nights that you have clouds, so you don't have a good measure of that. So we have the monthly measure of nightlight for each pixel. Each pixel in this NOAA data is, I think, about 700 meters square. 700 meter times 700 meter square. So we can locate every property that we know, all those properties that experience extreme rainfall, and we identify the recovery in them, and the recovery in them is basically what happens to nightlight in the 2 months after the into the 2 months after the event. So the hypothesis here is that nightlight is a good proxy for what is happening in terms of economic activity in that location. We're not the first ones who are using nightlight for that purpose. So that there's a whole literature that uses nightlights in economics to proxy for economic activity or recovery in using this information. So recovery is measured by what happens to nightlights after the event. The damage associated with the event is measured by the decrease in nightlight from the month before the event to the month of the event. Okay, and then we actually run a straightforward regression specification where we're trying to explain recovery, and the explanatory variables are what happens, the damage in the location. So each unit of observation is a house in New Zealand. Each unit of observation, is a house in New Zealand that experienced extreme rain. And then we also want to know what is the impact of the EQC claims. Okay, so whether a property submitted a claim, whether the claim was resolved, and whether they were paid for the claim within the 3 months that we are looking at. We also use other information from LINS, sort of topographical information, so slope and distance to water for each property, and information from Stat New Zealand, which is available at the mesh block level. So we can identify each house, which mesh block it is, and we can control for some socioeconomic factors. And basically what we do is we estimate this model, and I'm not going to go through the explanation, but the sample here is quite large because again, it's all those properties that experience extreme rainfall. And what we observed, sort of the 2 points I want to emphasize here is that there is a negative coefficient associated with the damage. So if you experience a lot of damage in the event, then your recovery was also faster in the few months after the event. So basically, the more you dip, the more you have to go up after that, which is not surprising. That the standard sort of kind of dynamics that you observe in shocks. The more you fall, the deeper you fall, the more you have to climb up. But we also find largely positive or insignificant coefficients for the EQC variables, which suggest, and this is sort of our punchline in this project, is largely we think from the evidence that we have is that the EQC scheme is working in terms of assisting in the recovery of the damaged properties, right? So if the purpose is to assist in recovery, presumably that is the purpose, or at least one purpose of the EQC, then at least for that purpose, the EQC scheme seems to be doing what it is supposed to do. But we want to note that not that many people claim. So there's only a few hundred claims per event. Forget the numbers, but the numbers are in the paper. The paper, by the way, should be available on Motu's website today, right, Sally? Not that we're talking about a few hundred claims per event. So why don't more people, while a lot of people are experiencing these extreme rain events? So the two possibilities. One is that all of the other properties that are experiencing the extreme rain are not suffering any damages. So they're not claiming because there's no damage. Or for whatever reason, they're not claiming, although they did experience some damage. We think that there's very few reasons not to claim for the EQC because the excess is really, really low and there is no premium penalty for submitting a claim. So unlike your car insurance, if you submit a claim for your car insurance, next year you will pay more, right? In this case, there's no penalty like that. So, and the excess is really, really low. It's, I think it was $200 for most of the time period. So there's basically no reason to not to claim if you have damages. The only reason you might not be claiming is because you're not aware that you can claim. So you're not aware of your entitlement to claim. We don't know if this is a major issue or not, frankly. And I think that's something that needs to be looked at, because in the future, if we're thinking about the future, and this is part 3, if there is changes in the awareness of this cover, then there might be changes in the amounts of liability that the EQC holds. I don't know if this is the case. I think most people I've talked to have no idea that the EQC provides coverage for weather events, so it might be an issue. Okay, so there are questions whether this very low claim rate will continue, but this is the data that we have. That's the history. So for the part 3 of this project, this is basically we have three stages here. I'm going to just describe you for briefly step 1 and step 3. So in step 1, we take all the previous history of claims by the EQC, and we correlate that to the EQC, and we correlate that with past historical rainfall information to identify the relationship, the statistical relationship between experiencing extreme rainfall and submitting a claim to the EQC. Okay, so we quantify that relationship between experiencing an extreme rain event and submitting a claim. And then we take, in step 3, we take those, why do we have these knocks? I don't know what's going on. Somebody's keep having those knocks. But anyway, in step 3, we use projected rainfall data in the future, again based on NIWA projections, and we using the estimates of the statistical relationship between past rainfall and past claims, we use that to conclude about the likelihood of future claims given future rainfall. Okay, so that's the and that allows us to estimate what is the future liability of the EQC, the likely future liability of the EQC because of climate change. Okay, so if we think of the first step, we're basically estimating the relationship across 4 kinds of variables in terms of the EQC. So we're talking about whether a likely there will be a claim or not. So that's the number 1. So the probability of a claim. We can estimate the number of claims in a specific cell. So what would be the predicted number of claims in a specific cell? We can look at the total payouts, because we know for each claim we know exactly how much it paid. So we can try to look at the association between extreme rainfall events and the amount that was paid for that cell. And we can also estimate the amount of payout versus the value exposed in each cell, because we can measure for each cell how much was exposed. So the value of buildings in that. So this is, because all of EQC is residential buildings. I should have noted that sort of in the first slide. It's only about residential structures, only about residential buildings, right? EQC doesn't do anything about commercial buildings since the EQC Act of 1993. Okay. So for step 2, though, some comment there. So we in step 1 we use the observed history, and what we want to correlate that is ideally with the observed future. So if we had a crystal ball, we would know what the future rain would be for the next 80 years in every cell in New Zealand, and we could correlate that with, given the statistical information that we observed from the historical data, we could then know exactly how much the liability of the EQC will be. This is if we had the crystal ball. Alas, we don't. So we need to rely on modeled future rather than on the actual future. And NIWA thankfully produces that modeled future, or specifically HABA, is part of the team that produces this, this future. So we have modeled future rainfall. So basically what we're doing in step 1 is we're looking at the observed history. In step 3, we are using the modeled future. But we wanted to ask in between, we wanted to ask whether these two series are actually similar enough so that we can, whatever we find from the past history, we can conclude from that about the modeled future. Now, thankfully, we have the modeled history. Okay, so the same models that were used to produce the future rainfall predictions are also can be backcasted. Thank you. So they can be backcasted to produce a history or an alternative history of past rainfall. So what we do in step 2 is we're comparing the observed history and the modeled history to see whether they match each other. Now, they don't. At the tails, they don't match very well. So what we observe here is this is a map for each cell. What is the 95th percentile for one-day accumulated precipitation in the actual history minus the modeled history. So the actual history, the tails are the 95 threshold, 95 percentile threshold of observations in each cell in the actual history is higher, generally speaking, than the modeled history. That's at least what my the other people who work on this and actually can see colors told me that this map shows. And in some cases, we actually observe that the difference is significant. So we're talking about up to 69 millimeters for 1 day of rainfall, where the 50th percentile is different. So that's 69 millimeters per day is quite a lot it's quite wet. So there is a difference. So what that means is that we need to adjust our model to account for those differences in the tails between the model and the observations. So we are using the thresholds in the modeled history. We are using to look back here. We are using the statistical relationship that we identified with in the observed history between the observed rainfall and the observed EQC claims, but we are using the threshold from the modeled history rather than from the observed history, because we think that the modeled history is more comparable to the modeled future. These two series are more similar. So that's what we need to do in step 2. And that brings us to the punchline of this model. And this is what will happen, what we predict will happen to EQC liabilities in the future. And this is the average of the 5 or 6 models, 6 models. So this is the average of the 6 models. We have the same, of course, we can produce the same kind of diagram for each model separately, but this is the average for the 6 models across the 4 RCPs, and in those sort of 20-year buckets from basically January 1st to 2100. So, so not very surprisingly, you see that EQC liability, and this is percentage change in EQC liabilities relative to current EQC liabilities for weather events. Okay, so we are predicting EQC will have more liability in the future associated with climate change. This is only associated with climate change, so this is not associated with changing exposure or changing vulnerability. So exposure, for example, will probably increase EQC liability as well, because there will be more people in New Zealand and more houses. But we're ignoring all of that. So we're only looking at the climate change signal here. So we predict increase in liability up to worst case scenario RCP 8.5 all the way to 2080. So that last is so up to 26%. So in the sort of the abstract of the paper that you've seen, we say it's roughly between 7% and 26%, depend on the kind of scenario you're considering, depending on the time horizon, and so on. So that's so not very surprisingly, there will be more increase in liability later on in the future, rather than in the near future. Worse RCP, so the higher RCPs, the more there's the more we emit greenhouse gases, the worse the increase in liability will be for the EQC, and the differences in the RCPs appear later on. So if you look at the blue. If you look at the blue line, there's not much difference across them, because this is in the next 20 years, the different RCPs are not going to make much of a difference in terms of EQC liabilities. But later on, of course, at the end of the period, whether we are in RCP 2.6 or RCP 8.5, that makes a big difference. So it works according to what you would expect. Right, and maybe one more thing we want to maybe show you is that RCP 2.6, for example, the liability at the end of the period goes down rather than goes up, and that's because the concentration of greenhouse gases in the atmosphere goes down towards the end of the century, according to this pathway. Right, so it's not surprising that the liability is also going down. Or it's not going down; it's going up, but by less. Okay, now because this is predictions about what will happen annually to EQC liability, that means that the EQC premiums will have to increase by as much, at least, to account for that, because this is experienced every year. This is not like earthquake that happens only once in a while. Okay, so EQC premiums will have to go up by that, and if the current calculations about EQC premiums and how much it will take to replenish the National Disaster Fund and so on, don't account for that, then that means that they are overestimating how quickly we will be able to accumulate, because they're not taking into account this increase that is already there in the next 20 years, right? So we already observed this prediction in the next 20 years. Two qualifications here. One is that we are assuming that the relationship between extreme weather events and EQC liabilities will continue to be the same. There might be some reasons why they might change. We talked already about awareness of EQC cover, but maybe something else that came up with the discussions we had with EQC is that the topography of New Zealand is largely shaped to accommodate a specific distribution of rainfall. So, even an extreme, 1 in a 100-year event has been experienced in the last few thousand years in New Zealand. So the slopes of the topography of New Zealand already can hold that, or has been able to hold that kind of extreme in the future. But if we are going to start experiencing extremes that we have not experienced before, then that might change the relationship between rainfall and so very extremes that we haven't seen before. The topography of New Zealand is not able to hold. So that might be one reason why there might be a change in the relationship between liability and rainfall. The other thing is, of course, we're assuming that everything stays constant in terms of regulation and in terms of the EQC Act. The EQC Act has just changed this year. So liability has increased for the dwelling from $100,000 to $150,000. That's already a change that's not in our data because, you know, we looked at data from 2000 to 2018. And that, of course, at that time period, we had $100,000 of cap on the dwelling. So that changed. The cap on the land is also changing because the value of land is changing. The cap on land coverage is the value of the land. That is changing as well in New Zealand as more people are here because of population growth and because of immigration. The value of land increases. The amount of land we have here is sort of fixed. So value of land will go up and that will increase the cap on the EQC cover, and therefore there might be, and those things might generate regulatory responses, and there are other things that will generate regulatory responses, and you're all aware of I think you're all aware of discussions about insurance retreats and all these other issues that are happening in the private insurance market, but affect the way that the EQC cover will be sustained going forward. So assuming that, you know, I'm willing to bet that assumptions about the regulatory consistency is not valid for 2080 to 2100. So EQC cover will not look the same in 60 years. So if anyone wants to take that bet, I'm happy to. But that's, of course, what we are assuming here. And that's, of course, what we have to assume here, because we have no idea what that new shape of law will take place when a new government sometime in the future decides to change it. That's as far as I have to add. I do want to note that this part 2 on using the nightlights to look at recovery is available online, or will be in the next few minutes, hopefully available online on the Motu website. Part 3 is going to be available before the end of the year, which that's our hope, because we need to sort of finalize some things about the estimations. But largely, we think that the estimates we showed you today will remain the same. We just want to make sure that they are as robust as they can be. And that's it. Questions?
Thank you, Ilan. That was a fantastic presentation. We don't have yet any questions that have been asked via the Q&A function at the bottom of Zoom. Yes, we do. One's just come in. It seems to be a long comment, so as a writer, can I ask you please to keep your questions short and to make them questions rather than comments? You can discuss with each other via the chat panel if you have comments. In the recent earthquake events in Canterbury, some green-zoned land sunk below the high tide levels. The Avon River mouth moved a kilometre upriver. Due to this earthquake-induced subsidence, substantial numbers of properties have been identified as erosion-prone. Erosion is not covered by EQC nor by private insurers. Still, people are repairing and rebuilding on land along waterways subject to erosion, etc., etc. What is EQC liability for these 5,000 erosion-prone properties along the waterways in Christchurch?
It seems to be more of a legal question rather than an economic question. Erosion is specifically and explicitly excluded in the EQC Act. But what is the difference between damage from erosion and damage from storm surge? Not entirely clear. But clearly that's a cause for celebration for lawyers, the fact that it's not clear. And I'm sure that lawyers will be able to get income from that. Yeah, I don't really have a good answer other than, I don't know, it's a legal question. Right now, erosion is explicitly excluded. Whether that's going to change, I doubt that. There's no discussions about anybody taking on this liability of erosion. And if we think about climate change and sea level rise, I think that the last thing you want to do is to that the government take that liability of erosion, because that will generate exactly the wrong signal for developers and local councils.
Thank you, Ilan. Can I also just let people know who are attending in physical hubs that you can raise your hand if you have a question? Anyone here in Wellington or online? That's a no? Okay. Oh, we've got another question. Thank you. I've got one here from Jason Kelly. Have you used your data to make claims predictions for future storm events, for example, cyclones in Auckland?
No. One could potentially develop scenarios for specific events, and we are part of one project that is trying to develop such a scenario for Tauranga, but that's not work that is completed, and we haven't planned to correlate that with the EQC claim data to try and estimate future EQC claims. Most of the damage from those kind of events is probably going to be storm surges, from storm surges, and there's very few observations in the EQC data that are because of storm surges. So, you know, a storm like, say, the 1968 storm, the one that sunk the Wahine, or the couple of years ago, there was a fear of a big storm surge in 2017. So, you know, a big storm surge will generate a lot of damage in, say, Auckland or around there. We couldn't really establish EQC liability because there's very little history of that. Yeah.
I'm just going to pass this microphone over to you, David, I think it was. But in the meantime, a question from Carl Bayliss. How many weather claim codes is the EQC going to have, from one currently to how many?
Sally, do you remember what they said? They said, I think 3, if I'm not mistaken. So I think it was storms, landslips, and floods. But that's something that the EQC will be able to better respond to.
If we have someone from the EQC zooming in, so Sally confirms 3, but if we have EQC people zooming in, you can raise your hand in the chat panel and we can turn your microphone on if you'd like to comment. But I'll pass to David Ratt. Thank you, David.
So thank you very much, Ilan, for a really interesting presentation. Question I had, there's a new IPCC assessment present.
Yes, I know.
Including an Australia and New Zealand chapter, which would be nice to see this picked up in. You mentioned that these papers are going to go up on the MOTU website. Are they also going to be published in a peer-reviewed journal? Because, yeah, if so, hopefully they'll be in before the publication deadline, and we can make sure that the lead authors know about it.
We will try to publish them. We haven't submitted them for publication to a journal. I think according to IPCC guidelines, the MOTU working paper is still, because it is peer reviewed, it's still eligible to be included. But our intention is definitely to publish this, but that hasn't happened yet. And just to add, in economics, we have a tradition of putting everything online before it gets published officially. So we're following that tradition rather than the scientific tradition of keeping everything close to your chest until you publish. Mm-hmm.
Thanks, Ilan. And just to repeat David's question, which wasn't clear to all of our audience members, it was a question about more or less how to have this research be included in the upcoming IPCC report, specifically the chapter on Australia and New Zealand. Also, just to note that Keredwin of MOTU has provided a link to the MOTU website where the report has just been published in the last 30 seconds. So you can get that through the chat panel. It will also be available on Ilan's project page on the Deep South Challenge. Not as fast as Keredwin, so give me a day maybe. We have a question, before we come back to the NIWA room, we have a question from Judith Swan. Does the modelled climate future include an increased number of weather-related events? The model presented was based on a single event in each year.
So the model is looking at the frequency of extreme rainfall projected in the future when the extreme rainfall is identified as the 95th percentile of the past model. So yes, there will be, the model does account for higher frequency of extreme weather events as they appear in the modeled future rainfall.
Thank you, and I'll just pass to our friend here at NIWA, Greta Point, if you could introduce yourself, please.
Brett Mullen. My question, your research indicated that there might be an increase of up to 20% in the liability by the end of the century for storm damage. Could you give us some idea of the relative importance of earthquakes versus storms? Because of earthquake liability is much higher than storms. Now, a 20% increase in the storms may not be that important.
So if you take out the three big events, the three big earthquake events that EQC paid for, which is the 2010, 2011, and 2016 earthquakes, then this risk is a substantial part of the portfolio of liability of the EQC. But if you add these three events, then everything else is dwarfed by those three events, right? And just the 2011 event is way bigger than all of the other events in the past 50 years combined, right? So now if you really want to assess the relative importance, then you need to have some kind of view of what is the probability of a Canterbury earthquake event happening. I don't know. My seismologists have opinions. My seismologist friends have opinions about that. But they also have a track record of being not very accurate with them. So I don't know the answer. That's the answer. We do have. I don't remember off the top of my head, but we of course know exactly the dollar value of what EQC paid for weather events in the past 20 years. That's in the first paper. I don't remember the number though.
We have a question from Tom Fitzgerald. Are there particular districts or local government authorities that are disproportionately represented in the data?
Yes, that's also in chapter 1. And yeah, so for example, Nelson, Hawke's Bay, if I remember correctly. So there are regions that have much higher per capita likelihood of submitting an EQC claim or being paid by the EQC than others. And all of that comparison is done in the first paper and publicly available.
And a question from Mike Harvey here at Wellington.
Yeah, just wondered if there's any evidence of relationship with large earthquakes between the slips and extreme rainfall relationship, so that maybe there's some interaction. I just wondered if there's any evidence of that in terms of claims, liability.
Not in the data. We haven't looked specifically at that, but in the second chapter, we only look at those events that they didn't correlate with any kind of a big seismic event. So that's for part 2, those 3 specific events that we looked at. I don't think we have identified anything in particular with the either the big seismic events that we had in the last 10 years. I don't recall any kind of spike with those events in the data. So there is a potential, of course, and there was an extreme rain event after the Kaikoura earthquake, but largely in not very populated areas. So not much evidence of EQC claims associated with that, because these are only for dwellings, right? But other than that, no, not really. But of course it's a possibility, and there's a whole stream of research in the Resilience National Science Challenge Phase 2 to to look at these cascading scenarios when sort of two events happening at the same time or roughly at the same time, and whether that sort of amplifies the damage. In some scenarios, of course, it does. The likelihood of this happening is not very high. So whether that's an important issue from an economic perspective, I'm not sure, because we will need to look at the joint probabilities. Clearly, the probability of an earthquake is completely orthogonal to the weather. Well, I think it is clear, but that's at least my ignorant view of both the weather and the plates. If it's completely orthogonal, then the joint probability is probably very, very low.
We still have a couple of questions in the chat panel, but we also have 15 minutes, so please feel free to keep those questions coming in. A simple question, perhaps not. How likely is it that certain things will become uninsurable? Is it possible?
So EQC insurance is conditional on private insurance, on you having private insurance. If you don't have private insurance, you don't have EQC cover. Okay. At this point, we don't really have a sort of a sustainable mechanism to provide EQC cover to somebody who is unable to get private insurance, because largely it hasn't been an issue until now in New Zealand. So houses could purchase private insurance. Whether that we could, I think we could probably argue that that's changing as we speak, rather than as a future issue. And we've seen that, we've seen discussions on that in the media in the last year or so, with IAG saying they do cover Wellington, and then saying they don't cover Wellington, and then saying they do cover Wellington, and then saying they don't cover Wellington, and so on and so on. So is it possible in the future? Well, private insurers are only about covering infrequent risks. So, I think a sort of a good heuristic is nothing that happens more frequently than 1 in 50 years will be happily covered by insurance. Because if you want to cover something that happens more than 1 in 50 years, then you will have to pay at least 2% of the value of the asset. And since usually the insurance charges maybe twice as much, then 4% of the value of the asset every year to get it covered. So that if you think of your house and 4% of that, you will find it very painful to pay that every year for insurance just for a specific peril. So it's in all likelihood either insurance will withdraw from specific locations or just stop covering specific perils in those locations. That has different implications for the EQC. So if they stop covering storms and floods, the EQC insurance is still applied, because it's only the condition here is that you have fire insurance for EQC to be part of your coverage. But if they decide to withdraw and stop covering at all, then of course you don't have EQC either. Whether that's happening, I think it's already starting to happen. Whether it will happen more in the future, clearly, because the probability of events in specific locations is increasing. So once they pass that threshold, say a 1 in 50 years, it's no longer insurable.
Thanks, Ilan. A question from Dan Schwartz. I believe, Dan, you're coming to us from Melbourne, not from Wellington City. Are there comparable studies for other insurers globally? Because as a domestic study, this only provides an incentive for cost-effective adaptation. From a global perspective, it's an economic motivation for mitigation.
There's very little research globally on insurance, because very few people have access to data. So we are fortunate that the EQC is very willing to share the data. Even some public insurers are willing to do that elsewhere. Private insurers are not willing to share the data globally. So there's very little. So in some sense, what we find here is unique to New Zealand, because the specific structure of the EQC cover is unique to New Zealand. I mean, if we do a comparison of public insurance systems globally, each one is different. And we're actually doing a comparison now with Sally on sort of comparing global public insurance systems and the differences between them. So in some sense, the conclusions here are only local because the specific institutional or the specific clauses in the covers. But I think it is general. Many of the sort of implications of this are generalizable globally as well. And I hope I answered that question.
I'm sure Dan will comment if you
Yes.
didn't.
Please.
A question again from NIWA. Could you please introduce yourself?
Stone here. Thanks. I've been handed the microphone, so I may as well speak. So if you look at the precipitation by intensity, daily precipitation, say by intensity, we expect the really heavy events to increase under climate change just because those storms, supposing they still exist and everything are the same, can hold more water and then they dump it. But overall, there's an energy constraint in the atmosphere that requires that precipitation generally increases at a lower rate. So we expect the less intense events to become less intense. So the less intense days. So the point where you kind of cross from actually a decrease in that distribution to an increase is actually about the 80th percentile or something like that. Yeah, I guess it depends on location and everything, but it's fairly high up. So I'm just thinking that the 95th percentile is what you expect about 18 days per year to be exceeded. So it's not very extreme, and it's not at this extreme tail where the sort of thermodynamic argument holds. So I would actually imagine that those really extreme sort of events that are causing the claims would actually be affected more than the 95th percentile.
So we do the same analysis for 99th percentile as well and 98th percentile,
Yeah.
Which all of that will be in the paper. So in some sense, that's a response, I think, to your concern. We don't find very significant changes in the patterns, do we, Jacob? Or we haven't done the analysis enough to say that yet.
We've done for 3 different percent.
Can you talk in the microphone so that the people...
So we've done our analysis of extreme precipitation for 3 percentiles, the 95th, 98th, and 99th, for up to 5 days of accumulated precipitation to take into account the antecedent conditions. But when we're running our regressions, we see that the 99th percentile of 1 day of accumulated precipitation has the highest coefficient. As for what you were saying about extremes not being extremes, a follow-up of the project is to use actually the high intensity rainfall design system, because you actually get actual extremes, 1 in 250 and so on, and first of daily durations. So we are going to investigate the relationship between these actual extremes and the EQC liability payouts, insurance payouts.
So
A question from Sir Rosia, or a response, I guess.
Did you use a threshold, your 95th or whatever percentile, did you use a threshold from the past, and you looked in the future at how many more times that's exceeded? Or
Yes.
did you look at the 95th in each case and see how much the
No, the former.
is right?
So we established the 95th percentile using the modeled history, and then we'll see how many times it's exceeded in the future model. Mm-hmm.
We have a question here from someone anonymous, which might be a Zoom issue rather than someone wanting to remain anonymous. But if you're out there and you can identify yourself via the chat panel, I think that might be helpful. Anyway, the question is regarding the current risk assessment. NIWA and EQC are in the process of updating the risk assessment in New Zealand due to insurance industry reassessment of risk, AIR worldwide and others. When will this update be available to the public? I'm not sure if if this is the general risk assessment or something specific to the EQC. I'm looking around for NIWA people who might be involved in the risk assessment and can't see anyone. Ilan, do you want to comment on that?
I have nothing to, I'm not aware of this.
I know that the National Risk Assessment it's having its first meeting as we speak, and they are likely to, they're supposed to be reporting back in April, May, whether seems quite a short time frame, but I'd jump onto the Ministry for the Environment website, has some really great information about the risk assessment, so that might be a place to start. Again, I can't see who you are, so I can't ask for more clarification. In the meantime, are there any other questions in the room? There's a comment from Carl Bayliss. We couldn't hear some of those audience questions. Sorry, Carl. I don't think that I'll go back and repeat them, but I will see if I can catch some of that and transcribe it and send it out after this. So I think that's probably all that we have for today. Thank you very much, Ilan. I'm sure that there'll be huge interest in the 3 papers when they're published, and also just as always a plug to keep in contact with the challenge, with the Resilience to Nature's Hazards Challenge and with NIWA and with Motu to make sure that things that are released publicly, that you're made aware of them. Jump onto all of our respective websites for the right links. Thank you very much, and maybe a round of applause for Ilan.